Alright guys, I'd really like to thank PCBWay for sponsoring yet another video of mine. Their 3D printing service is outstanding. They made all my rotors. This is the first one, which they made. This is out of aluminum. I just uploaded the file. This one is stainless steel, which is even crazier. This one is transparent resin. I didn't even know you could do that. And then, of course, the last one, or the second to the last one was my nylon rotor. Actually, the nylon rotor was first. So again, thank you, PCBWay. Link is in the description. All right, guys, so welcome back. I'm taking a break from my dual cone motor. Still can't figure out what to call it. I got some really good suggestions. Vortex motor. There was a few other ones. I'm probably gonna, I'll figure it out. But I have my stand here, which, sorry, I turned my video off by mistake. My stand here, which is a great stand, and I rigged it up now where I have these magnet holders, or they were originally going to be these guys here, where I was going to just use these as a stand-in for the bearings, but I didn't print them correctly and they're too loose, even though I made holes in here to put set screws in. Anyway, I wanted to see if I could get two of my PCBWay rotors. This one was the very first one I had them do for me, which is made out of aluminum. And this is the latest one, which is crystal clear acrylic. Actually, it's not acrylic, it's resin with a varnish finish. And the magnets are close enough to interact. And what I want to try to do is, I know they'll work like this if I get them to go like that. I know it'll work like that, but what I want to do is to get them to anti-gear. I'll show you what I mean in a minute here. Let me get it going the regular way. I'm just running it off of a single coil JL94 circuit from Sky Collection. And these are floating on these magnets here. This one's kind of cockeyed though. I got to fix this. But yeah, let me see if I can get it going. I don't even know if it's going to work. I'll see if I can get it going. I tried it with this guy, which is my stainless steel rotor, but it didn't seem like it was going to work. So let me fire it up and I'll bring you guys back. Stay tuned. All right, so it's working. It's at, let me turn it down. It's at 13 volts. It's at 12 volts. And I have it so that the shafts aren't spinning. I have this little cap up here which glues the shafts down, but it's working great. This particular circuit doesn't have any output, so the little neon's taking a beating. But it's running nice and quiet and nice and smooth. But what I want to do is I want to stop one of them and see if I can get it to anti-gear. Right now it's spinning this way, and so this one's spinning this way and this one's spinning this way, the normal way it would, the normal gearing. But what I want to do is stop one of them and see if I can get it to anti-gear. So stay tuned. So I'm trying to get it to anti-gear, which would be spinning it that way, see if it would connect, but it's not doing it. Doing it a little bit, but once I go like that and it gears. I gotta figure out which way this guy's going. Oh, maybe once I stop it, I take it out of the system and it won't start back up until I shut everything down. Huh, that's interesting. Let me bring you guys back. Stay tuned. Yeah, it's really weird. So it's showing up on the video like it's not anti-gearing, it's regular gearing, but once it gets in sync, but I want to see how much is coming off of this coil now in back EMF. So let me hook up my new GochaFix multimeter. Where is it? Let me hook it up and I'll bring you guys back. Stay tuned. All right, let me see what I can. So I have it set up for AC. Yeah, so the back EMF is 15 volts coming off that coil with the 2 rotors spinning. It was registering 17 just a minute ago. Let me see. Supposed to be able to push F1 down and it should go into oh, maybe it's auto. No, it was I'll have to read the instructions again. I could have sworn it was you get it in AC and then you press F1 down and you hold it for 3 seconds and it should go into scope mode. Let me try. Maybe it's anyway. So the back EMF is like 15 to 17 volts. Nice and quiet. All right, let me bring you guys back for something else. Stay tuned. All right, so I figured it out. It was press auto for a couple of seconds. I don't know what I was thinking. It's a nasty waveform. Let me see if I can do this one-handed. I don't think I can, but let me try. There it goes. And you can see 9, 10 volts, 27 hertz, 41 hertz, fluctuating. Pretty cool though. I don't know what I'm going to do with that information, but it's cool. All right, stay tuned. Sorry about that last shot when I was trying to get the leads on there. I was like way down like this and it was probably look crazy. So I want to put my nylon rotor up there. This thing is a beast. It weighs, God, it must weigh like a couple of pounds. I want to get it on there with another beast I have that's just as big from my redesigned 3DP, what was it, Newman motor. It's a beast of a rotor. I want to get them both on there, so stay tuned for that. Yeah, that's a big rotor. That's the nylon one I had PCBWay make for me. I design it in CAD, send it to these guys, and they print it out for me because I can't print out. And it's done through an SLS process, but with nylon. So selective lasering or selective laser sintering, whatever it's called. But yeah, I got the big one, and now I've got my very first one. Probably killing this poor circuit. So that neon bulb for me is solid. For you, it's blinking. But I want to get the other big rotor on, so stay tuned. Yeah, these two guys are monster rotors. This guy almost took my finger off putting it together. I had to, excuse me, 3D print special jigs just so I could get these. These are, I think, what are they, 2-inch by 1-inch by a 1/2 inch, or 2-inch by 1 inch by 3/4. They're huge magnets. These are 1-inch cubes. equally dangerous, and all of them are N52s. Let me dare to get this puppy going. Stay tuned. It'll get up to speed. It's starting off slow now. I'm at 12.6 volts. Probably terrorizing that circuit. Uh-oh, stay tuned. That wasn't the circuit. They're just interfering with each other too much. Even though it's 4 on 4. Yeah, they're just interfering with each other too much. But it was fun while it lasted. Let me see if I can get it going one more time. Oops, sorry about bringing you in so close. Yeah, no, it's not going to work. All right, stay tuned. I really like this rotor. This is a really nice rotor. It's so smooth. But the magnets are just too powerful. They overwhelm each other, shake the stand to pieces. And yeah, what I want to do is I want to wind another coil like this, another big one, but I want to wind it in a bifilar configuration. So I think I'm going to try that next, but I want to get something else to run with this guy. What I may do is put him in the middle and put 2 coils on the outside and see what I can get. Because now I have this stand rigged up where I can do all kinds of different configurations, although I got to fix this. I don't know if you can see that, but it's on an angle. I thought I had it straight, so I'll have to knock this bottom one out and slide it over, or knock the top one off and slide it over. I think that's what I'll do, because I have more room on the top here to slide it over. And I don't even know how it's, I think this is just crazy glued in. Excuse me. But yeah, those are beasts. All right, stay tuned. So stupid. I just figured out why the 2 rotors didn't work. Look at that rotor carefully. What do you see missing? There's no bearings in this the way there are in these guys here. And I locked off the top bearing, so it couldn't spin. If I undo the top bearing, then it will spin just fine. I just went to try to fire it up by itself, and I'm looking at it, I'm going, wait a minute, why is this not spinning? And it's like, duh. I have it locked off on the top there. Well, you know, mistakes are always made, but that's part of the learning process, making mistakes, right? All right, guys, stay tuned. So I have it unlocked now, but it's probably a good thing I didn't get it started, because I think the shaft is bent. I know I have one of these stainless steel rods where the shaft is bent, and I think that's it. So it's a good thing that I probably would have shook the system to pieces. Anyway, I'm going to get the other one back on there, but I'm going to put a new shaft in there, and we'll see what we shall see. Stay tuned. Yeah, that's the way it should be going. Makes a lot of noise because it just makes a lot of noise, but it's not as quiet as the other ones where I have the bearings on the rotor themselves. There's a bearing up here, and there's a bearing down there, and then of course it's floating on the magnetic bearing down there. It does make a lot of noise though. Alright, let me get the other one back in there. Stay tuned. There we go. The 2 beasts. I don't have this one floating on there because of the cocked thing, so it'll just stay right there. I wonder if I can get these guys to anti-gear. Probably not. Anyway, that's enough of that. Stay tuned. All right, guys. So I've been tinkering with making a new coil support piece here. Oh, I forgot. I've got to get some more clips on here. Anyway, this goes like this. And I designed this because the first ones I made, where are they? the first ones that I made for the side here for holding the coils were a complete accident. I didn't realize that this thing fit on there like that. So I took that happy accident and decided to make one on purpose. So I pushed that guy in there like that. And then goes like that. Coil goes on here. And then this little piece right here. Oh, this little piece right here goes on here to hold the coil in place. So yeah, let me get it set up. And I want to do this because this is a special coil that I got from Sky Collection. It has an input and has a pickup side, but I think both sides can be used as pickups because I have the two drive coils in their new sliding housing. God, I love 3D printing. And this is the nylon rotor that was made by PCBWay. I designed it. They printed it. This is a nice rotor. I put the insert piece in there because it was normally hollow in here. Anyway, let me get it set up and we'll get some measurements going. All right, stay tuned. All right, so I wanted just to test it to make sure that there's no vibrations. This thing's holding up pretty good. I'm printing out 2 more brackets for around the corner there. Wow, these lights are really bright. So these 2 lights here are the 2 back EMFs coming from this dual circuit. What I want to try to measure is this coil. So let me get it hooked up and bring you guys back. Stay tuned. So in playing with this new scope that I got from Gotcha Fix, I like it, but I wish it came with better clamps. I don't like these, these single probes here because you really can't do much with them. So I ordered these guys. These, you can press this down and the little clip comes out. It's so much easier to hook wires to it. I also got these. I don't know why I got these. These are some monster clips. But these guys should work really well. Hopefully they fit. Oh, you got to be kidding me. They don't fit in the thing. Oh, man. All right. So they don't fit. Great. But I think these guys fit. I'm pretty sure these guys fit. Yeah, these guys will fit. Yeah, they'll fit. And these have, you can take these out, and I think I can hook. Yeah, okay, great. So I can hook these guys to the ends of these because they do come out. So I can hook those to there and then use these clips. Thank God I got these extra ones. Anyway, disaster averted. Stay tuned. So it's working, but I got nervous at first because I put these on here and it wasn't working. This is reporting this 9-volt battery as having 6 volts DC, which is correct because I use this battery for a lot of stuff. Anyway, I went to do this and I didn't push it down far enough. I thought it would only go, I thought it only went down that far. But once I push it all the way down, it does work. It's a really tight fit, but it does work. So, yay. Stay tuned. All right, so I have it hooked up. As you can see, I'm getting 10 volts AC, 11 volts. As it speeds up, I've got the little clips hooked on there. It's pretty cool. So what I did is I jumped this coil. So it's recording one giant coil off of it. And I want to see if it makes a difference. Oh, I got to tighten this down. See, I knew that's why I wanted to test this to make sure. So 14 volts AC jumping up to 15. I want to see if it's different if I just do one of the coils. I have it jump like I said. But what I really wanted to do is just test these clips. And I wanted to test this too. $16 AC. This is the pickup side, this is the input side, but like I said, I've got it jumped. So it's effectively one giant coil, $17 AC. It keeps going up. That's crazy. 18 volts. Wow, that's nutty. I didn't think I could get it that high. Now let's see what the waveform looks like. Again, I don't really know what that means. 20 AC, and it's 12.7 volts coming in. Of course, that doesn't mean anything. 21 AC, and this guy is spinning up. It continuously is rising. I don't know why. Because it's a cool motor, that's why. 23 AC. You guys can see that, right? Yeah. Uh-oh. It's reaching its limit because I moved it. 25 AC. Yeah, it's not reaching its limit. I don't know why it gave me a warning like that. Again, I really like this guy because of the old school fonts there, or the display. 26 AC, and it's still climbing. That's cray-cray. All right, let me shut this down because I want to just take a reading off of one side. But yeah, I want to get me in. I've got some DC converters here, some bridge rectifiers here. I've got this guy right here. I'm going to hook it up, see what we get. 27 AC, pretty cool. Stay tuned. All right, let's see what we can get on just one side, just the actual pickup coil itself. So much quieter since I don't spin the top and bottom bearings. I'm only spinning that one, and it is floating on. I don't know if I can get my thing down here so you can see that it is floating on top of that magnet underneath there, right there. $7 AC. I suspect it's not going to go as high as I had it up to almost 30 volts AC. I don't think it's going to go that high. Let's push this guy in a little bit further. Maybe it will. 11 volts. I just noticed that this coil is farther from the rotor than that coil. I have some new acrylic. I'm going to build a new housing. 13 AC. I have a feeling that's probably as high as it's going to go. I'll slide that over and tighten that down. It looks like it's tilting in this way, but it isn't. It's actually straight up and down. 15 volts just off that one side. It's not bad. It may climb all the way up. I don't think so, because by now it was about the same, 16 volts. All right, that's probably enough of that. So this is a really cool coil. I love that coil. It's done me really well. I got it from Sky Collection. as a gift. I was buying circuits from him and he popped that in as a gift for me, so that was kind of cool. All right, stay tuned. All right, so I've jumped the coil again, but now I have it hooked to this bridge rectifier unit with a big fat capacitor on it. And already I'm getting 12 volts DC, 13. It's speeding up really, I mean, it's climbing pretty quickly. One of the reasons I'm doing a test on all this is because I wanted to test this rectifier to make sure it was okay. And I want to use one pulse motor to power another. Of course, I'll have to see how many amps I get on it. But already I'm getting 18 volts DC. Really solid output on the back EMF. I could hook all that together and I should be able to. I screwed up and messed up my clamp. I put them too close to the front here. As you can see, my coil stand is now doesn't work right. Well, it happens. I can always knock it off and redo it. 23 volts DC. And it's funny, if I pick this up, it'll start spinning the coils up here. And it actually increases the speed. It also increases the noise, but I'm already at 30 volts DC, which is awesome. But I don't want to spin all the bearings. So now the bearings are spinning on the actual rotor itself, plus the two on the housing and the one floating on top of the magnet. 37 volts DC. Oh, it's going down. So if I let it go again, 36, 37, nice, but it makes a lot of noise. Oh, there it goes. If I just 40 volts DC. Wow, that is a good coil. This is also a good rectifier. $43 volts, 44 volts. Alright, I'm going to stop the shaft from spinning. Oh, maybe if I tighten down the... Oh, I see what's going on. Alright, 44 volts. Alright, very cool. Very, very cool. I have other bridge rectifier sets that I want to test. I have a homemade one that has a little LED display on it I want to try. Alright, stay tuned. So I realized during that last test, one of the reasons why it's rattling is this top that I made for this stand has brass screws that only go down so far, and I usually have more spacers in there. It's tightened all the way down, but you can see the spacers are loose, and that's what was making all the noise. So I have to redo the top, or I have to put some more spacers in there, which I have. I've got 3D printed spacers that I've made. So let me redo that, and we'll fire it back up again. Stay tuned. Yeah, you can hear the difference now that I tighten these down, but the whole stand rattles if it gets too much. Excuse me. That's why I got to make a new stand. This will be the last run of this one. Oops. Yeah, this will be the last run of this one. But I'm already up to 19 volts DC, which is freaking sweet. And if I pull this up and I get all of them spinning, it's still much quieter, even with all the bearings spinning. 29 volts. That's a great coil. Thank you, Sky Collection. Thank you, PCB Way, for always taking care of me. It's a great company, man. If you ever need anything 3D printed that's out of the ordinary, or even if it's ordinary, but like the nylon and the aluminum and the stainless steel, I had printed the rotors. 33 volts. Yeah, okay, this is cool. All right, I think I'll test one more thing. Stay tuned. So I wanted to test one of my bifilar coils, one that I made a long time ago. I'm getting 7 volts AC pretty quick. So I have a feeling it would work really well with the bridge rectifier. 10 volts. And again, I have it jumped to be one giant coil. And I forgot why I made this coil. I think I just wanted to make a bifilar coil for some reason. But it's producing pretty good output. 15. Yeah. I'm sure it'll do really well with the rectifier. 16, 17. Really nice and smooth. I love that rotor. Came out beautiful. It was a good design, but an excellent print. All right, I think that's all for today, guys. Up to 20 volts AC. I will be back with a new stand. Stay tuned.